Hey everyone! As I explained in the last video, by the end of this module, you'll be tasked with designing and building your very own Arduino system. Because of this, we thought there was no better way to kick things off in this module than to get you working with the Arduino hands-on right from the beginning. In this video, we're going to walk you through step-by-step instructions of how to build your very own Arduino circuit. We're going to use the knowledge that we build in this video and apply that later when we learn more about the theory of electronics and more sensors and actuators. To do this, let's introduce you to a member of the ENES 100 teaching team to show you how to get things started.
Hi, my name is Jacqueline Lopez-Rochwald, and I am an instructor for ENES 100. In this video, I'll take you through a step-by-step tutorial for making this nightlight. Right now, with the ambient light, this LED is off. And now we can see what happens when it's very dark. The first thing we will do is identify all of the components that we will need for the nightlight. We will need an Uno microcontroller and USB cable, a solderless breadboard, a 330 ohm resistor, which has the color bands orange, orange, brown, gold, a 1 kilo ohm resistor, which has color bands brown, black, red, gold, a photoresistor or light-dependent resistor, which has a dark red squiggle on the top, a two-pronged LED, a handful of jumper wires, and if you have it available, a 9-volt battery. Let's start by creating a controllable LED circuit. First, we will put the 330 ohm resistor in series with the LED on the solderless breadboard. I first bend the leads on the 330 ohm resistor such that I can place them into holes in the solderless breadboard. I am going to place one end in hole 1A and one end in hole A3. It does not matter which orientation I use when putting that resistor into the breadboard. The direction of the resistor does not matter. Next, I will put in the LED. The orientation of the LED does matter, and I'm going to place the long leg of the LED into the same row as this end of our resistor, which is row 3. So I'll put the long end perhaps in hole 3C and the short end in hole 4C. These two components are now in series. I will use the power of the Uno microcontroller to power this circuit. Right now, the microcontroller is not plugged into a computer or a battery, so there is no power running through it. I will wait to plug it into power until I'm confident that I have the appropriate circuit set up. I'll take this red jumper wire and plug it into hole 1C, and the other end of the jumper wire into pin 9 on my Uno microcontroller. Next, I will take a black jumper wire and plug one end into row 4, let's say hole 4B, and the other end into a pin on the Uno microcontroller called GND, or ground. To test if this circuit is set up appropriately, I will plug in the USB cable first into the Uno microcontroller. You can download the Arduino software by going to arduino.cc, then going to Software, Downloads, scrolling down, and downloading the appropriate installer for your computer. Once you open the Arduino IDE, you will go to Files, Examples, Basics, and Blink. Scroll down, and we will make one adjustment to this code. we'll find the 3 instances where this variable, LED underscore built-in, appears. And we'll replace each of those instances with 9. Once I've removed all of the instances of LED underscore built-in with 9, I can go to the upper left corner to this check mark button, which is called Verify. This button compiles the sketch and allows me to see if there are any errors. I click on it. I see that it is compiling. And then it says Done compiling, and there are no errors. Now I will need to make sure that my Uno microcontroller is connected to the appropriate port. In the Arduino IDE, I'll go to Tools, and then down to Port. I need to make sure that I've selected the one that says Arduino Uno. In my case, the default was COM3, and I need to change it to COM4. The numbers may very well be different on your computer, but you will need to make sure that you change it from whatever the default was to the one that says Arduino Uno. Now I will upload my code to my board. In the upper left, there is a right-hand arrow called Upload. This button will both compile and upload. I'll see in the bottom it says that it is compiling, and then it is uploading, and then it is done uploading. Let's see how the circuit behaves now that I have uploaded this code. Here I can see that my LED circuit is working. Pin 9 is controlling the LED and making it turn on and turn off. I will now create the light sensor for my night light. First, I will unplug the USB cable so that my Uno microcontroller is not powered. I am going to place the components for my light sensor in a completely different part of the breadboard to ensure that it's not interacting at all with the LED circuit. First, I'll take the 1 kilo ohm resistor and I'll plug one pin into hole 30I and the other pin into hole 28I. Next, I'll plug the photoresistor into hole 28G and hole 26G. Next, I will take a red wire and I will plug it into hole 30J. I'll plug the other pin into the first hole of this red strip at the very bottom. Next, I'll take another red wire and plug it into the red strip as well, so a few holes down, and connect the other end of that red prototyping wire into pin 5V on my Uno microcontroller. Next, I'll take a black prototyping wire and plug it into row 26, column J, and the other end into this blue strip. It is very important to ensure that this black wire is not in the same strip as the red wires. I will then connect this to my Uno microcontroller by putting one end of a black wire into the blue strip a few holes down, and the other end into a pin on my microcontroller that is called GND for ground. I have one more wire to connect, which is my signal wire. I will pick any color except for red or black for this wire. I will place one end of this wire into hole 28F and the other end into pin A0. I have now completed my nightlight circuit, and I will plug my USB cable into the microcontroller and into my computer. Now I will download and open the Nightlight logic code, which can be found in the Nightlight assignment. I'll verify that I am still connected to the appropriate port, and then I will upload. It would be helpful at this point to see the sensor values that are being read by the light sensor. To do that, we will go to the upper right corner and click on the magnifying glass, which is called the serial monitor. I observe that in my room, the ambient light is producing a sensor value of approximately 930. And then when I cover the photoresistor with my finger to simulate that it's very dark, my value changes to about 1000. You should take a note of your two extreme values. What value do you get when you have ambient light? And what value do you get when you have it fully dark because you're covering the photoresistor with your finger? Now you will need to decide an appropriate cutoff value that is safely between those two extremes. In my case, I might choose a cutoff value of 960. I'll go to my code and I will see where there is a cutoff value of 876 by default. And I'm going to adjust that now and replace it with my appropriate cutoff value. Now I will re-upload my code. Now let's look at the expected behavior of our circuit. With ambient light, the LED is off. And when I cover the photoresistor with my finger to simulate that it is now dark, the LED turns on. The last thing that we will do is disconnect the USB cable from our microcontroller. We'll take our 9-volt battery and connect the 9-volt battery barrel connector. And take the barrel connector and plug it into the microcontroller. At this point, your nightlight circuit will function the same way as it did on your computer, but now you have the flexibility of bringing it into any room.
Congratulations, everyone! You just built your very first Arduino circuit in ENES 100. Give yourselves a round of applause. Excellent, excellent work. You should be really proud of yourselves. The lessons and concepts that we covered in this video, we're going to go over those even more throughout the rest of the module. In just a few short weeks, all of those nightmares you used to have about the Arduino are going to be long gone as you become experts in electrical systems and the Arduino. I'm confident and look very much forward to seeing all of the great things that you're able to achieve throughout the rest of the semester.